We're going to have a go at filling in this table to investigate the product rule when differentiating. So we've got some functions listed there in the left-hand column. What we're going to do firstly is to expand them. So if we expand out this first one, we would get x squared, then we'd get minus 3x plus x minus 3. So that would simplify just to be x squared minus 2x minus 3, which maybe you would do that in one line. Then we would differentiate that. So dy dx would equal 2x minus 2. We should be pretty good at doing that by now. So that's what the derivative is. And then in this final column, we're going to rearrange this dy dx, but we're going to rearrange it in terms of the two brackets that were multiplied together at the start. So that was x plus 1 and x minus 3. And if we just put an addition in the middle of those, we can see that x plus 1, x minus 3 gives us 2x minus 2 as required. So just by adding those two brackets that were multiplied together, we get that. So let's move on to the second one. If we expand this out, we get y equals x squared minus 2x plus 4x. So we get plus 2x in the middle and minus 8. Move on to the derivative, dy dx. If we differentiate that, we bring down the power, so we get 2x and then plus 2 this time. If we write down the two brackets that we started with, x plus 4 and x minus 2, and add them together, we can see we do indeed get 2x plus 2, which is equal to the derivative. Okay, let's take it up a notch. This time we've got two brackets multiplied together, but there's a coefficient of 2 there, which is possibly going to make things slightly different. So when we expand, we get 2x squared plus 6x plus x plus 3. So 2x squared plus 7x plus 3. We differentiate dy dx and we get 4x plus 7. We do the same thing. We start with the two brackets, 2x plus 1 and x plus 3. But this time when we add them together, it gives us 3x plus 4, which is not what we want. Okay, but what we notice is if we put a 2 in front of that bracket, we would get the 2x and 2x, which is 4x, and we'd have 1 and 6, which would give us 7. So that does give us the 4x plus 7 by putting that 2 in front of the second one. Okay, we'll do one more. When we expand this one out, we get y equals 6x squared plus 4x minus 3x minus 2, which is 6x squared plus x minus 2. When we differentiate that, we get 12x plus 1. Writing out the two brackets as a sum, by adding them, we would get 5x plus 1, which is not what we want. But what we notice is if we put we have to do a little bit of thinking for this. It's not always easy to spot, but we're going to spot a pattern. It will become easy eventually. But for now, you're just going to have a little play. In order to get the 12x, what I notice if I put a 2 there, that would give me 6x. And if I put a 3 there, that would give me another 6x, which would give me the 12x. It also, in this first bracket, will give me minus 3, and in the second bracket will give me positive 4. So in total, it will give me the 12x plus 1. Okay, what we've got to try and spot is how did I know to put a 2 there? How did I know to put a 3 there? Where did that 2 and that 3 come from? And we've got to try and spot the patterns. But for now, I want you to have a go at filling in the table that's similar to this in your books. and have a play at that final column, and then later we'll figure out what the rule is for differentiating products like this. Okay, so here's a couple of harder questions. Maybe you've had a look at some of the ones from the booklet, or maybe you haven't yet, but here's some of the couple of harder questions. I'm going to do them in the same way. So I'm going to expand them out first of all. So I'd get y equals x to the power of 4 plus 4x squared plus x squared plus 4. So that is x to the power of 4 plus 5x squared plus 4. So these are no longer quadratics, which is why they're a little bit harder. dy dx, when we differentiate this, we would get 4x cubed plus 10x, and the 4 constant on the end would disappear when we differentiate. So the same idea, we're going to write the original two brackets, x squared plus 1 and x squared plus 4. Now obviously I know the answer already because I know the rule, but you're just going to need to have a play around as to what coefficients to put in front of those brackets. X squared and x squared is going to give us a 2x squared, but we're looking for an x cubed, so clearly there's going to have to be an x out the front of those brackets to make there be a cubic term. So what I'm going to do is outside the front, I'm going to put 2x here, and I'm also going to put a 2x here, because when I expand that out, I would get 2x cubed plus 2x plus another 2x cubed plus an 8x, which hopefully is going to give me the 4x cubed plus 10x, which is the same as the derivative. Okay, let's go do another one. Y equals, expanding this out, I would get 2x to the power of 4 minus 2x squared plus 4x squared minus 4. That is 2x to the 4 plus 2x squared minus 4. The derivative dy dx would be, bring down the power, would be 8x cubed plus 4x, and that minus 4 would disappear in the derivative. Writing out the brackets that were in the question, 2x squared plus 4 and x squared minus 1. The coefficients that I want to put out the front of this one is 2x, and out the front of this one is 4x. Have a think about maybe where I got them from while I expand this. That gives me 4x cubed plus 8x plus 4x cubed minus 4x. That gives me 8x cubed, yep, that's what we wanted. And then 8x minus 4x gives me the 4x. Brilliant. So still trying to work out where I got these coefficients from. And the last one I'm going to do then, expanding it out, y equals 6x squared minus 6x to the 4, that would be, minus 3x squared plus 4x squared minus 2. That is y equals 6x to the 4 plus x squared minus 2. The derivative then would be, bring down the 4, would be 24x cubed minus 2x. Rearranging the original brackets to get the derivative, the coefficients that I want to put out the front are 4x out the front of this one. Any ideas for this one? 6x. Okay, let's check. If I were to expand it, this would give me 12x cubed plus 8x. This would give me 12x cubed minus 6x. That is 24x cubed, and positive 2x, which I had minus 2x over here for some reason, but when I check, I was differentiating that, so I should have had a positive. Did anybody spot that? Excellent. So it does work. So what we've got to do now is spot the pattern, if we haven't already, as to where we get these numbers from. Okay, so have a go at doing the ones in the book and pause this video, do the ones in the book, and then come back to this video and we'll have a little chat about the rule that we've hopefully spotted. Okay, so hopefully you've had a go and had some success with filling in all of those ones in the book. And now we're just going to have a quick look at where these came from. So what we say, if we look at this first question here, we'll call it question 1 at the top. What we did was we wrote the first bracket, x squared plus 1, and we multiplied that by 2x. The 2x, if you haven't already spotted it, is the derivative of the second bracket. If we differentiate the second bracket, we get 2x. Okay, and then what we did is we wrote the second bracket, the x squared plus 4, and we multiplied that by 2x, which is the derivative of the first bracket. Okay, moving on to question 2. Okay, the first bracket was 2x squared plus 4. We wrote the 2x squared plus 4, and we multiplied it by 2x at the front, which was the derivative of the second bracket. Then we wrote the second bracket, x squared minus 1, and we multiplied it by 4x, which is the derivative of this first bracket. When we differentiate that first bracket, we would get 4x, and the plus 4 would disappear. So checking that with the third rule, we write the 3x squared plus 2, and we multiply that by the derivative of the second bracket. If we differentiate this second bracket, we would get 4x. We write the first bracket, 2x squared minus 1, and we multiply that by the 6x, which we got from the derivative of the first bracket. Okay, we'll discuss this more when I'm back, but hopefully that's made a little bit of sense, and I challenge you now to do example 9 in the booklet, which is the example after this table. See if you have any luck with it, and after that you can go back to the math space, which is revising all of the differentiation so far, which some of you started last lesson. All right, good luck with that.